I'm going to try to do Advent Code 2021 day 20 and then 21 when it unlocks. And I hope that it's not a disaster like day 19 was. Although you see here I did complete day 19. Not many people did compared to the other days. Day 19 was the toughest, I thought. I gave up, and then like an hour later went back and did it, and I still got under rank 1000. So, what is Advent Code? It's an advent calendar of programming puzzles. You can see here it goes from December 1st to December 25th. Each puzzle unlocks at midnight Eastern time. So, an hour and 20 minutes or so, day 21 unlocks. And day 20 unlocked yesterday. I didn't get a chance to do it, so we're going to do it today. And they're Christmas themed. It's a pretty cheesy theme every year. So this theme today, or this year, is we dropped the keys to Santa's sleigh into the ocean. And we got to get in our submarine and chase down where those keys go. And we're nearing the ocean bottom. I'm guessing at day 25, we fight a sea dragon and talk to an emperor fish who teleports us back to the surface, because that's the whole plot of... never mind. Spoilers! Anyway, let me get set for days 20 and 21 by making a copy of day 19. Discord knows so. Thank you, A Squared. Hi. I should do that, yes. Points, A Squared, 2 points. Advent Code, no stream plan. I'm going to try days 20 and 21, starting now. There we go. Okay. Gonna have a 20 doc text. Can't wait to get my new keyboard so I don't make all these mistakes. What am I saying? I'll make mistakes. There's different kinds of mistakes. It would be the learning new key maps mistakes. Oh, I should go over what my day 19 solution actually was. For anyone who happened to be watching and saw me rage quit, let's just kill all of this. And then copy over that. Part two. Time before I got too wrapped up to announce it this time. Yes, thank you. I appreciate that. We'll put a placeholder for day 21 while we're here. Okay. Mod day 20, mod day 21. Next year, I think we're going to be using some crate that does some of this for me. Might just try a standard one, or, I don't know, it might be fun to write my own. Who knows? I always like to write my own things. I feel like I learn better when I write them myself. And I have fun. These don't compile because we don't have a 20.txt or... oops. A 21.txt. Oh, I discovered something while I was editing videos for YouTube, so I should not type while I code, because I have these really obvious gaps in my speaking when I alternate between writing code and speaking about it. I can do things that don't require language processing, like I'm doing now, but yeah, it doesn't work when I try to write something that requires language processing. I should always just pause and talk before I do, and you know, like that. I just paused between when I wrote 20 and 21 there. And it's mostly annoying when I'm editing my videos and I end up making jump cuts because I will flip-flop between talking and writing code. Obviously, I'm like multitasking and like each thread is getting a second. All right, is anything else I need to do here? 2021 cargo run 21. They should all say not implemented yet. Okay. So for anybody who saw me rage quit, or maybe you didn't, I don't recommend seeing the VOD because yeah, I was pretty upset. Here was my solution for day 19. Where to start? I think I did this much on stream. Right. I did this much on stream. The parsing. So the input looks like this, where you have like different scanner outputs. And for each scanner, it detects beacons relative to the scanner's position, but you don't know the scanner position and you don't know the scanner's orientation in space, other than that it's pointing up, down, left, right, forward, back, and the, what do you call it? The orientation, like up, down direction, can be one of 4. In all fairness, everyone you talk to, does AOC severely struggle or didn't finish day 19? Yeah, I was looking at the leaderboard and it's obvious. Not the leaderboard, the stats. Look at that gap. See that? So a lot of people didn't finish. Maybe half? Right? If we follow that curve down, I'd say half people didn't solve it. Right, so this should be a 20,000 here, I think. You know what's kind of good this year is that most people don't get stuck on part 2. So these are the people who didn't do part 2. Most, I would say, well, okay, maybe not. The last 3 days, at least part 2 was easy if you could get part 1 done. This is an order of magnitude bigger. These might be just people who try and they struggled and they had to stop, right? These large numbers, because usually day 1 is pretty easy, so if you should be able to do both parts, unless maybe you're new to programming or trying a new language and you're really struggling, or you just don't have enough time to do them. Anyway, yeah, day 19 was rough. So anyway, we get a bunch of these scanners, and the job was to try to match them up to determine how many beacons there are and where the scanner positions are. 1/9 of all the people who did part 1, yeah. So let's explain the parsing. So I decided to put the scanners in a vec DQ because later on I'm going to try to resolve where the scanners are one at a time, just in a circular loop until whenever I find a scanner match, I'm just take it out, and we'll just keep cycling through that until it's all empty. So vec DQ is what we decided to use. I don't think I need this type anymore, but anyway, this current scanner is the one we're building when we're parsing. And first I get an iterator for all the lines, and then I say, while there are lines, we take the next line and we trim white space off of it. And then we see, are we building a scanner yet? If not, we're going to start building a scanner. So this eats the first line right here, because we don't really need anything from this line. It's really just an extra line. So I put it there. That's why we started this at none. Eat that extra line, and the next line through is going to be a beacon. So there will be some scanner, and we'll parse that into coordinates. So we implement it from string for coordinates, and then insert it into the scanner. And then I think this is because I couldn't figure out how to borrow current scanner mutably within a while. So usually when I struggle with borrows, I will go to a trick where you can move stuff in and out if you own it, right? So we take the scanner out of current scanner, because you can do that with an option, and then you can put it back in. When we get to that empty line, that's the signal that we are at the end of one scanner, and we're going to be getting the next scanner. So we take the scanner, we completely built it now, we push it into the scanners. And because we've taken it out of current scanner is none again, so the next line through, we discard it by creating a scanner, and we keep going until we get to the end of all the lines. And at the very end, there won't be a blank line. necessarily. So if we still have a scanner that we're building, we just immediately say we're done with that one. So that's the parsing. It's pretty straightforward. So here's the hard part. So I started this brute force solution and thinking this is not going to work, so I abandoned it. But I went back to it after the last stream when I rage quit and cooled down and went back to it, right? So I put a lot of it into these functions: find, match, reorient, etc., etc. The overall thing is that we're going to first take the first scanner. It doesn't really matter which one, just the first one in this case, and then we're going to keep trying to pull off another one, and if we can find a match between the two scanners, like as in that we can find an overlap of 12 or more beacons, then we're going to insert all the beacons that we find in the new scanner into the map. So basically the map is initialized with one scanner's data, and then we fold another scanner's data into it if we can find a match. So when we find a match, we get two pieces of information. We get what orientation the second scanner had to be put into to find a match, and we have an offset between them in space, so like an XYZ offset between the two scanners. So that's the information. With that information, we can take every beacon and reorient it along that orientation and move it by that offset, and that will then map it onto our reference, and then insert will do nothing if it's already in there, but if it's not, it's adding a new beacon, because in the end we want to just get the number of beacons, right? So basically we want to find out which beacons are unique and which beacons are redundant between scanners. If we couldn't find a match, we put the scanner back into the back of the VEC DQ, so that when we pop the front, we're going to try a different one. Now, it's possible if there's a scanner that doesn't overlap any other scanners, we'll just go into an infinite loop over and over again, pulling it out and not finding a match. But that never happens with the real data, so it's nothing to worry about there. Okay, so this find match. Here's this nasty thing, and I think I got to this line and I said, screw it, this isn't going to work, because it is it's 3 levels of loop there, but then there's a 4th one here, right? So there's like 4 nested loops, and I'm like, there's no way that'll run. The universe will run out of energy before that point. So I just gave up, but I really shouldn't have. So what we're doing here is we're trying all different orientations, and there are 24 unique ones. People I talked to have said that there are 48 or 64, but those are the ones that include mirrorings along planes. So those we never find a match on. These are the 24 actual orientations where you could possibly find a match on. And I'll go more into that in a minute. So for every orientation, we take every point that's already in the map, and then for every point in the scanner, we try to find if we reorient that point with one of the 24 orientations, and then we move it to map it on right onto left. Then we count how many times when we apply that same orientation and offset to all the other points in this that's right-hand side scanner. Does it also match what's already on the map? And if we get at least 12 of them, then we found a match. So I thought that this would be enormously expensive, and it's pretty expensive, but not too bad. So I can cargo run 19-1, and it's running. Debug build's slower than release build. It'll eventually get it. Release build takes about 5 seconds. So I really should have run the release build, actually. But while it's going, I'll just continue explaining. So then, what are these orientations and what does reorient do? This is where the knowledge that I picked up for linear algebra and computer graphics kind of came in handy. So what these orientations are matrices. They are basis translation matrices. They're coordinate transformation matrices. They all mean the same thing. Yeah, it runs. It does run. Debug can be orders of magnitude worse. Well, we'll see if it finishes before I'm done explaining it. If it doesn't, then I'll just hit Control-C and run the release build. I did end up thinking the coordinate transformation stuff was not so bad. This would have been funny for me to do on stream, because to to type in all these and to make sure I did it right, I had to basically hold my hand out in front of me, right hand rule, right? Your index finger is the x-axis, middle finger is the y, and your thumb becomes the z-axis. And I was just like holding my hand out in front of me, like all the different ways, and saying, how do we construct these matrices? So the idea is that if you take a vector in one coordinate system and you multiply that vector by this transformation matrix, you get the same vector in a reoriented coordinate system. Right, and if you try it in all 24 of this, then you find the same vector in all 24 possible orientations. Hey, look at it, it's finished, and actually got the right answer. So a lot of me holding my hand in front of me, trying to like figure out which axes were which on every single rotation, and I grouped them by like, this is where the x-axis is what I define to be forward. So a 1-to-1 between input and output x, and then negative x is when you turn it around, and then positive y is where the input x-axis points to the y output axis, right? Negative y and then z, negative z. The hard part was to fill in these two because you have to pick the 4 combinations that are still right-hand rule and are unique. Right? You don't want to have 2 that are essentially the same or accidentally mirror it to left-handed coordinate system by mistake. Yeah, it only took a couple minutes. I'll do it again on release. This should only take like 5 seconds. So the matrices are pretty simple. There's an array of arrays of I sizes, 3x3s, and there are 24 of them. See? Much faster release build. So then what does reorient do? It's just doing a matrix multiplication. Easy, right? Linear algebra. So you just take the x coordinate and multiply it by the leftmost column of the transformation matrix, and then add the y coordinate times the middle column, and then the z coordinate times the right-hand column, and you add them together, and that forms your new coordinate. Yeah. Now, I was concerned that I might have gotten the matrices transposed or backwards, but it actually ended out working. I suspect that I could have used left-hand rule or right-hand rule, and I could have done this multiplication transposed, and it still wouldn't have mattered. Where was I? I think we'll end up finding a match even if I got this transposed. It probably would have worked either way. Anyway. It's just the names might not be exactly right. So there's some things subtly added in here, like how do you subtract an offset? That's done by implementing sub. So that's member-wise subtraction. And then for part 2, it was just adding on this little thing at the end where you have to know how many where each scanner was, and then compute the maximum Manhattan distance between 2 scanners. So that was, I just did brute force that as well. I said, pick something on the left, pick something on the right, and then I didn't even bother if left was the same as right, because there the distance will be 0 anyway, so it will never win. And we just find the maximum of all of those with this Manhattan distance function, which is taking the difference in each coordinate member-wise absolute value and adding them. That's the Manhattan distance. As long as it's consistent and covers every order, yeah, I think so. And this could be expanded to any number of dimensions. So if we went to 4-dimensional stuff, these 3s become 4s. This would jump up by a significant number. We would have a 4th thing for Manhattan distance. We would have a 4th coordinate. We would have 4 sums and 4 columns and 4 rows. And subtraction would have a 4th one, but not much else changes really. The parsing would have a 4th parsing. Yeah, I think I was talking about that during the stream, that when you reduce problems like this, spatial problems, into ways where you can separate the dimensions, especially like with basis vectors, adding on more dimensions is easy for a computer to handle. Hard for a human to visualize, easy for a computer to handle. It's just multiplying the problem a little bit in terms of the time it'll take and the amount of memory you need. Depular solutions on GitHub, I can't. I did finish day 19. I finished it after I rage quit the last stream. I cooled off and I went back and did it. And it ended up being the brute force solution. It takes about 5 seconds. It looks awful because it's got the nested loops, but it works. And then talking to a lot of other people did the same brute force solution. A few people got it running really fast, and their trick was to find the edges between points. And there are a couple other tricks. And I don't remember exactly what they were, but I didn't care. I didn't like day 19. It kicked my butt. So I was happy going on to just finishing it, and we'll go on to day 20. So I need to catch up. I'm a day behind. Like, as always, I only gave myself an hour, so probably won't get it, but I heard a rumor that day 20 is easier than day 19. So let's try it out. So day 20, trench map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. Day 20 is easier. That's good, because I'm going to try to do it in an hour. When you get back the image from the scanners, it seems to just be random noise. Perhaps you can combine an image enhancement algorithm and the input image, your puzzle input, to clean it up a little. For example, the first section is the image enhancement algorithm. It is normally given on a single line, but it's wrapped on multiple lines in this example. For legibility, fair enough. Second image is the input image, a two-dimensional grid of light and dark pixels. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in the input image into an output image. Each pixel is determined by looking at a 3x3 square pixels centered on the corresponding input image pixel. So to determine the value of the pixel at 510, the 9 pixels around it, these are combined to a single binary number that is used as the index into the image enhancement algorithm string. Okay, it's not really image enhancement, it's more what would this be called? Decoding. So this is like the encoded output, and this is the, well, these are pieces of the encoded output, really. We're just decoding it. To determine the output pixel corresponds to the very middle pixel. Yes, I'm wondering what they're going to say about the corners and edges. Zoom, enhance. Yeah. Okay, starting from the top left and reading across each row, the pixels are that, then that, then that. Combining these is that by turning. Okay, dark pixels are 0, light pixels are 1. You get a binary number, which is a certain number in decimal. Okay, and then we use as an index into the algorithm. It's exactly 512 characters long, enough to match every possible 9-bit binary number. First few characters of the string are as follows. In the middle, this first group of characters. So 34 is there, so it's a light pixel. Okay, got it. The images are being operated here are infinite in size. Every pixel, the infinite output image, needs to be calculated exactly based on the relevant pixels. Is only a small region of the actual infinite. The rest consists entirely of dark. Okay, that's how they handle the corners and the edges. If it's out of range, we pick a dark one. Only a portion of the infinite size input and output will be shown. Okay, this is just an elaborate... They could have just said, if it's outside the image, pick dark. All right. Oh, are we going to iterate on it? Oh, cool. We'll get to iterate on it. Zoom, enhance. Zoom, enhance. Truly incredible. Now the small details are really starting to come through. Start with the original input image, apply the image enhancement algorithm twice, being careful to account for infinite size. We can do that. That's no problem. Okay, so that's our output. Yeah, this one seems fun. I like it. I want to change the correct day here, though. All right, so then 35 for the input, which is up here. And I got to be mindful that that's one line, not a bunch. So I will need to join these lines together. Like, what's the easiest way to join here? Like that. Oh, that's going to screw up the auto formatter, isn't it? I'm gonna undo a little bit. Yeah, how am I gonna do this without messing up the auto formatter? I think I am going to do a concat. And then just arbitrarily pick points in here. And just break it here. And then we have to actually handle these ones too. Can I do this and put a new line on the ends here? Oh, I forgot the opening ones here. There we go. Yeah, that looks a bit better, right? And then a new line there, and then they want me to have another new line there. Because when we do concat, it's taking out all the new lines. So I got to put the relevant ones back in there. So is this gonna? Okay, well, we'll make sure that that works. So we're going to have one line which is the algorithm. Let algo equal input. Well, let's first get let line mutable lines called input.lines. This is lines next unwrap, and then we're going to want to skip one, and then for every output, it doesn't tell us how big it is, so let the what are we calling it? Image equal lines.map line to line.chars dot map char match char. If it's a hashtag, it's is that light? So a true dot is a false, and everything else is unreachable. And then we're going to collect that into... I might change this later. I'm thinking I really want to put it into just a hash set, maybe. But we'll collect it for now. Dot collect and then another vector. Let's turn on this inlay hints again. We moved it. Where did I move it? Oh, right. I can't just do that. I keep forgetting that that has no output. There's no... Sorry, it does have an output. This doesn't do with the side effect. This actually wraps the iterator with one which skips. So we want to put the skip in there. Okay. Test text files. Nah. I'll just do this one. It's fine. Okay, then let me think about how to solve this. Yeah, I think I'd rather put them into hash set because to do this, it's really just do 9 lookups based on coordinates. Because if I put it into a hash set, I don't need to worry about the bounds because they can just grow to any size that I want. I know what I can do. I can do an enumerate here. Enumerate. And I can also do an enumerate here. Then we get two things. We get a y coordinate and a line. And then here we get two things. We get an x coordinate and a character. So what I can do here is map this to some x, y, and I can map this one to none. And I can collect these all, well, I can just not collect them, right? I can flatten here and then collect it into a hash set. Hash set needs to be imported. Okay, that's not exactly what I wanted to do. I didn't want hash set of options. I thought collect into a hash set would drop the nuns. Oh, I know what I want. I want a filter, don't I? Don't I want a filter map? Okay, and then this needs to be put into something else. Expected enum option. I thought that's what I did give it. Oh, shoot. I don't want to... That is a map. It's like filter flatten. Is there a filter flatten? I guess I'll just do it this way. Map. Well, filter map. Chord to... I just chord, right? Oh, okay. What's wrong with this? Closure cannot live, but Y borrows. I didn't think Y would borrow. Y would look like a U size to me. Okay. Do I just have to say copy? I don't get it. What am I borrowing here? Oh, yeah, just do the recommendation. Move. So that forces it to make a copy of Y, which is fine because it's just an integer. And okay, it's going to tell me what I can do better here. Filter map with identity. Try flatten. Oh, flatten twice? Oh, interesting. So you can just flatten it twice. One flattens the two iterators together, and the second flatten removes the options. I didn't know that. Well, see? The Rust compiler teaches me something new every day. So then it's a matter of just doing this a certain number of times, and they told me 3 times, right? That's the starting image. 1, oh no, it's just 2. Let's make a constant for that. So const enhance steps equals 2. All right, then 4 blank in enhance 0 to enhance steps. I suppose we just form a new hash set from the input. Yeah, so, let me think about this. It's actually a little bit harder, right? We have to find the extremes of the x and y coordinates and go out to so like this corner and this corner, and we'll do this corner even though it's 0 and that corner and that's 0. Yeah, if there was a hashtag here, we would have a problem, right? Because that would mean the infinite grid would explode in light pixels. So fortunately, we don't have that. I should just get the input while I'm at it. Get my puzzle input. Oh wait, the first one does have a hashtag. Isn't that going to present a problem to us? Isn't that going to make, like, index 0 would be... So what did they give us another rule that gave us a bound? I guess we just have to assume the bound increases by 1 every time. And the fun begins. Closures borrow other captures, yes. What is the answer that they want us to have? Oh, wait. is it twice on purpose? Yeah, okay, so if the infinite field does because what I'm thinking is like, let's say we pick these three way out here, right? That does add up to a 0, and in a real input, that would light it. So everything would get lit, right? But then if you go another step, everything here will be lit, but the last one, that'll map to the last index, but that'll turn it back off. So I guess it's okay as long as the first and the last, as long as the first one's either an off, or if the first one's on, then the last one has to be off. So we can just ignore everything outside of the, we don't have to compute output pixels for everything way out here, but for these corners though, we have to be careful, because after step 1, everything will be lit instead of not lit. And that affects how we compute things on step 2. I realized that far sooner than you did. I can see that would trip people up, because like I had to like say, well, where are our boundaries? And I'm like, oh, wait a minute. If these do form a valid index, so then what would that light it or not? In my case, it does. And in their example, it didn't. So I consider that a trick. Where was their input? Yeah, see, they didn't. But if it was all lit, it would stay lit. Interesting. So I got like 45 minutes left. See, realistically, we only need to expand this by 1 each time, right? So I can just keep it simple. I can take the square root of the number of points. No, I can't do that. If I didn't reduce these to a hash set immediately, I could have just well, no, while we're at it, why don't we just let mute x range equal 0 to 0. Let mute y range equal 0 to 0. And we'll just mutate them in here. So we'll do it here. When I move that, though, that's going to be a problem, right? Can't do this without a move. I can do this without a move if... Hold on. The only reason I did a move here is because Y would have moved in. But what if we, like, had a... where is it? Here, we can let Y equal borrow Y. And then just do that, right? Then it doesn't need to be move. Wait, it still does? Why is that a problem? Can I return a value referencing? I'm not referencing it. I'm dereferencing it. Hey there, Code Monk, and Pro Table Flipper. How are you? Use collect to allocate the iterator. Can I return value referencing local variable Y? Returns the value referencing data owned by the current... It's not referencing data. I dereferenced it. Is it not? Did I not hit save? No. That's weird to me. Weird. Well, we'll just move it back. Move. Okay, but I want the side effect of updating these ranges, and I'm not sure how to do that, because this move is going to, like, move that range in there. Maybe rather than trying to figure that out, I can have an intermediate stage where it's a vector of vectors, and then the x and y range are just the size of the 2 dimensions. So maybe I'll just do that. So hold on. We'll do this in 2 steps, even though it pains me to do so. We don't enumerate. We just map. So we just get a line. And here we don't get an x, we just get a character. And this becomes a true, and this becomes a false. And we don't flatten twice, and we collect first into a vector, and in both places, yeah, so here we have to collect into a vector as well. And don't flatten there. So the image is first a vector to bools, and then we can get our next range, and then we can consume the vector and turn it into a hash map. Okay, so then the y range is just 0 to the image.length, not exclusive, and then x will cheat, and we'll say there better be at least one line here. Image index 0 len. Okay, and then here I'm going to take image into iter, and then enumerate, and then map, and then see, instead of chars here, we just enumerate, or it into iter, enumerate, and then this is true. Actually, that we can just change. Instead, we don't even need a match. We can say it's C then sum. C then XY. Easy peasy. Double flatten into hash map. Do I have to say sum there? Oh, empty closure. And that, you guys can't see. Oh, you can see. It's right above my head. Right there. Look at that. So that gives me a hash set of coordinates, and we have the range of those coordinates. So then every step we can expand out one, and we need to remember if the ones outside our range are considered zeros or ones, right? So that's an extra variable we need to have. So actually, I don't need to expand the range. I can just know what step we're on. And the step number is what we're going to like subtract from the minimum, add to the end, to the maximum. I'm going to want to make these into I sizes though. So where's the most convenient place to do that? Turn this off. Give me more room. We should do it here. If I did like there and there and there as I size, then it's a range of I sizes, and then I have to do it here as well. Okay. I can just do a trick here and make that an I. And step is an I size. Okay, then, oh yeah, we'll just say let, well, I already know it's going to be inverted. Well, okay, I could just program in the knowledge that my input is going to invert the boundary every step, but it won't work with this test case, which doesn't invert, so we should just have the code check it. So invert boundary is if the algo 0. What is that? Oh, I never parsed it. I should just reduce that to a vector of bools, right? So next unwrap and then map, well, chars, map char to match C, collect vector of stuffs, true. Oh, I already had it down here. extra parentheses. No. Why is this not formatting? I have an error somewhere. Down at the bottom? Ah, yeah. There we go. So we invert the boundary if we see a true there at in the first step. So, okay. I have to go through the ranges, right? For y in y range, well, I might as well just expand the range every step, right? That's the easiest way to do this. So at the end, we would say, oh, I need to make these mutable. Y range equal y range start minus 1. And I have to use parentheses here, right? To y range end plus 1. Same thing with x. I can't do that. Why not? Ooh. It got moved somewhere. Oh, right here. Borrow. Clone? Cloning a range should be pretty cheap. Okay, so then for x in x range clone. And we're actually going to want to expand it at the very beginning, right? Yeah, so these are computing the output, so then that means I want to have a let, this should be immutable. This should be like next image equal hash set new. And at the end, we're going to do image equals next image. Okay. We can do a y equals borrow y, then the inner closure returns a reference to that y. That's the thing, though. I didn't think the inner closure returned a reference to that y. Oh, is it because it's inside of a map? Okay, yeah. Yeah, that trips me up sometimes. Remembering that the lifetime gets extended to be all the way until we collect, right? And so if you think about it from the point of view of collect, it is using a reference after it would have been out of scope, but I have a hard time thinking of it. Yeah, that stuff I still have a hard time thinking of. Thank you for the follow. All right, so then we're going to do this image enhancement algorithm, apparently, where we take this is the point that we're computing, and then we take the ones in all 9 squares around it. So I'll just make it easy on myself and make an array for that. So const neighbors will be what? An array of 9 size tuples. And we have to get it in the right order. So -1, -1. And I already did this wrong. Thank you for the follow there. I appreciate it. And then the one to the right of that would be, if it's x and then y, it's 0, -1, and then 1, -1, and then these 3 again, but with these coordinates. Hold on, let's do multi-cursor here. Zeros, and then these are all, whoops. Multiple cursors again. And I didn't do that right. Try again. 1. Okay, it's just telling me I haven't used it yet. We'll use it, don't worry. Make sure I get it in the right bit order. So, hold on. Yeah, it's most significant to least significant, right? Yes, so that's 32, and then that's 2. 32 plus 2 is 24. 34. Hey there, CTF Lag, how are you doing? yeah, so then we're going to say for let mute I equals 0. And then for, we don't need a variable there in neighbors. We're going to borrow that to because we're going to do an iteration of that. Actually, I do need something here. What am I talking about? This is offset. Then I shift left 1, and then if image dot contains. Hey there, Metro Dev. How are you doing? Just found out that multiple cursors watching them. Or yeah, you just control click in VS Code. No, sorry. Alt click. Alt click, it makes you multiple cursors. And then if you want to do keyboard only, for me it's shift control and then no. Shift Alt. I get screwed up because when I go between Windows, Linux, and Mac OS, they're different key bindings. But yeah, when Windows it's Shift Alt and then up and down to make a wall of cursors, or Alt click to add another cursor. That's pretty handy. And it's not just VS Code that has it. I think Vim has that too, right? No. Visual Studio has it. I think Sublime has it. Anyway, if image, I need to put a value here. So that value will be XY offset by offset. So we might need to make a function to do this. And actually, I can just compute them in place, right? If I turn this into XO, YO. So this would be X plus XO dereferenced, Y plus YO dereferenced. And I need to borrow that and get rid of these there. Then the output one will insert it there. So next image insert. No, I jumped ahead. It's just I plus equal 1. Because at the end, we say if algo index I, then new image insert XY. Right? New image needs to be mutable. Next image. So I didn't need step. Oh, hold on. I forgot something. We need to check if something's on the boundary. What I really need is the previous range and the next range. So let's say let next x range, let next y range, and at the end x range equals next x range, y range equals next y range, because I want to have both the previous boundaries and the new boundaries, because then it's here where I have to be careful, right? If x in x range, actually it's x range contains, right? X, whoops, and y range contains y. Then we do this. Else, if invert boundary, then the condition is if the step mod 2 equals 0, I plus equal 1, right? What's this telling me? Collapse nested if block. Oh, this? Is that what it wants me to do? Okay, so I think I got it now. If the what the position we're looking at is within the old boundary, then we can look at it in the image. But if it's not, we have to check, are we inverting the boundary? And if so, are we on step 1 basically, or step 3? It's 0 based, so step 0, I guess you can say. If you're on step 0, then we are going to light up. We are going to... No, it's the opposite. I have this off by 1. It's as if equal to 1. If we're on the step 0, it's everything outside the boundary is off. But if we're on step 1, then everything on the boundary is on. Yeah. So anyway, this computes the new index, and we look it up to figure out what to put there. Should I test to see if I got it? First try? I hardly ever get it first try. I didn't get it. Not yet implemented. What? I mean, not yet implemented. Oh, right here. Ah, shoot. What was the... What were we supposed to return for the answer? The number of lit pixels. That's easy. It's just image.count to string len. Count, length, size. They all mean the same thing. Nope. We're off by 10. There are a few enough pixels where we can just print out what it will be, right? We can say debug here. Run here. So 2, 0 gets lit. It's kind of hard to see it. This is the starting image where that's 0, 0. Wait. This is wrong then. Oh, hold on. No. That's not right. There's some negative numbers there finally, but why does it say 2, 0 gets lit? It should have lit 0, 1 first. Oh no, that's outside the area, right? Yeah, it should have been, that's the original position, right? There are 5 there. 1, 2, 3, 4, 5. 5 there. Yeah, so where's the corner? It's hard for me to see it. It's on the 6th row and the 6th column, right? 6th row and 1, 2, 3, 4, 5. So there's the origin. So the first one should have been 0, negative 1, not 2, 0. So the problem is earlier than that. Maybe we should print out what the for each one what the algo I was. I kind of want to see XY with it, so let's just print it out. Print... How much time do I have? Like 25 minutes? X, Y, and I. And why don't we... put algo I in there as well. Yeah, let's see that. There's gonna be a lot of lines here now. Oh, wait, we're only considering positions that are lit. That's the problem, right? No, it's correct. Oh, I used the wrong one. It didn't do the boundary ones. Shoot. This should have been next X range and next Y range, next X range. Yeah, my bad. Okay, let's try again. See, getting debug output helps you visualize what you're doing wrong, because you'll see right away that, oh, we forgot it. 0, negative 1 should have been a 1, though, right? Oh, it's hard to see. No, these shouldn't be zeros, actually. That one was lit, so I got that wrong then. Are my neighbors wrong? No, my neighbors are right. Why did it not see, So this is like negative one to begin with, right? So the last neighbor should have put it to 0, 0, which puts it in range. Oh, hold on. This is the wrong range. Those are the wrong things. This should be, okay, yeah. Let, another variable name. So new x. How about x2? X plus xo. Let y2 equals y plus yo. Because that needs to be a 2, and then we're going to reuse them here. x2, y2. There's a phone ringing near me, and it's not mine. Whose phone is that? I think that might be Mrs. Reimuth's phone. Okay, that's what I was expecting, right? No, it's right down here somewhere.
Oh, thank you.
Yeah. All right. No, hold on. This is still not right. That is a 1. That's correct. Oh, here we go. 0, -1 is true. Okay, so this is correct, right? Did it get it right answer? Okay, it did. Okay, good. Let's try it on the, well, hold on. I was going to say let's try on the real input, but it's going to be huge until I maybe comment that out. Cargo run 21. We panicked. On line 25, during our parsing, we panicked on parsing. Something wrong with our input. Did I save that? Oh, I didn't. Oh, shoot. I thought I did. Where did I put it then? Did I just forgot to save my input? Let's actually save it this time. Yeah, make sure that that first one is one giant line. Yeah, it is. Okay. Well, that explains why it didn't work. The input was missing. Okay, so we got 4,928. What do we think? I'll get it in the first try? Of course I'll get it in the first try. After a unit test pass, that gives us confidence. On this part 2, I have 18 minutes. You still can't quite make out the details in the image. Maybe you just didn't enhance it enough. If you enhance the starting image 50 times... Oh, that's easy. This I should get really quick, right? This is enhanced steps part 1, and enhanced steps part 2 is 50. And then we'll just parameterize this. So this is inner, and this is inner input enhanced steps part 1. So this is steps, enhanced steps. I size, and we'll just use that here. And then this is inner enhanced steps part 2, and we don't need this one. And this is inner comma enhanced steps part 1. And then I just need to copy this to the unit test for part 2, and then they gave me a number 3351 for part 2, and make sure that this still works, right? Pass, and then will this pass? It ran longer, but it passed. So here we go. I still get 4928. Yes, part 2. It's running. It's running. It's running. It's running. More enhancement. 16,605. Yeah. All right. We did it with, what? 16 minutes to spare. Now, a lot of people did that one, so my rank is going to be like 14,000 something, right? Yeah. That's fine. Again, it would have been nice to know what my rank would have been, because I did this in, I don't know, maybe half an hour? I spent the first half hour explaining my day 19 solution, right? So another half an hour doing this one. Huzzah! Exactly. So I like that day. Let's clean this up a bit. Part of me says I should have consolidated this. I mean, I guess I could do that. Maybe here. Const test input string equals that. Then we can say test input. That makes it a little cleaner. Look at that. Probably been low thousands. Took you an hour and you're 1875. Okay, and hi Devil Squirrel, by the way. I'm happy when I get between 2,000 and 3,000, although I guess there aren't as many people doing it, and so I've been getting like sub 1,000. Low 1,000s would have been okay. I guess what I'm shooting for is 1,000. Let's run both tests actually. I can just hit this button. Okay. A little bit of cleanup here. So 14 minutes to go. Let's do a little bit more cleanup. I don't need this print anymore. In terms of making it faster, well, let's rename this, I guess, solve. And then move it out between parts 1 and 2. So that we're emphasizing that the only difference between part 1 and part 2 is the number of steps. Okay. How to make this faster? One thing I can do is bench, what is it? Cargo bench 22. See how bad it really is in release build. And I could use the profiler to see just really quick where the bottleneck is. It's going to take 35 seconds to measure this. So let's get the very sleepy out. Interesting. It's not using 100% CPU even. Oh, it is. Why does it say 6%? 353 milliseconds. I mean, it's not terrible. I'm just going to try to capture it while it's running right now. Why is it? Do I need to close it and open it again? It's very sleepy. Profile all. Okay, it's running, it's running, it's running. The profiling is running. Just let the profiler run the whole time. There we go. It's sampling it while it's being benchmarked. Did you do day 17 or skip it? I did day 17. I can go back and review that while I'm waiting. Got 11 minutes. While that's profiling, look at what my day 17 was. Yeah. I didn't like this one. This is the one where the input didn't even need parsing, and you're shooting things into an arc, right? I didn't like it because I didn't remember the math behind computing trajectories, so I basically brute forced it. Whoop, we can hide that for a second. I guessed the various IVY is initial velocity in the y direction. I guessed the range of it, and I screwed up on that and had it too low for a bit. And then for x, I reasoned out that that's a acceptable range for initial velocity of x, and we just tried them all and saw where we got the highest. And part 2 was, I think we just counted how many hits we got. So I did it. It's brute force. It's not nice. If I was better at math, I probably could have solved this without trial and error, without brute force. I didn't like it. I like the ones where there's some thought behind, like that goes into the parsing and stuff like that. Okay, so the most time we spent in hash map right. Okay, so our hash map is slowing us down. Interesting. Why is it highlighting that one? It's make hash that where we spent most of our time. Why is it highlighting that line in particular there? I don't know. Yeah, look at this. It's this hash map image contains. It spent a lot of time there. Wait, is this... What function is that? Hash brown raw impl next. Okay, so what? Okay, I shouldn't click on that. I don't know why it's putting that in yellow. Are you sorry, meant 19? Don't know why you said 17. The VOD is still up for day 19. I don't recommend watching it. I rage quit on day 19, but I did come back and do it. I went over at the beginning of today's stream. I went over what I ended up doing for day 19. Suffice to say that the parsing was good, and where I was going with the finding matches in the points for day 19 was okay for a brute force solution, but I'd given up early because I thought this would be impossibly slow. I should have just kept going. So the heart of this nasty, like, order n to the 4th power algorithm is just reorienting points and then checking to see if you move them to line them up with an offset if they match. And the reorient was doing a matrix multiplication, which was probably the only fun part of day 19 for me, was leveraging some of the knowledge I had on coordinate transformations. So this is how we represent all 24 different orientations, right? Using matrices, coordinate transformation matrices, to go from one coordinate system to another. So this does the orient and rotation in one step. And we use it here when we reorient. That was the fun part. I didn't like that I had to have this nested loop. Where was it? And basically brute force until we found matches. I mean, there's not a whole lot of code. It's just slow. How much time do I have? 7 minutes? It's internal function related to that call? Yeah. Hold on. This find match is called by the outer loop. So the outer loop is trying to find a scanner that matches. So if we have a match, okay, I need to close this so you can see it. If we find some orientation offset where we have a match between what we already have mapped and a scanner, then we collapse those two. Basically, this is a fold, right? Where you take every point from that scanner, you reorient and offset it, and you smash it into the map. But we might not get a match right away, and so it'll push it back into the vec queue, and then we just try the next. And we just keep trying different ones until we can find a match and remove it, and then we keep doing that until we have nothing left, and then our map, the size of our map is the answer. Yeah, so this find match is already inside a while loop, and it itself has 3 while loops and a loop here to count matches. This actually could have been more efficient if, instead of doing count, if we just stop when we get to 12, right? This is actually going to keep counting 13, 14, 15, etc. And at the end, it's going to like, okay, did we get 12? I could probably have sped this up a bit, right? How would we do this? Is there something that consumes an iterator and simply just tells you if there's at least 12 of them? Fold? Not fold. I thought there was something. There was something that you can use on an iterator that will just, like nth. Couldn't I just use nth and then say if it is some? Yeah, couldn't I have just said, if scanner dot that nth 12 is some? That would have worked too, right? And then that would have stopped at 12. Yeah, let's actually see. Let's see if that sped it up. Cargo bench. Actually, I think the benchmark's impossibly slow. Just run release 19-2. So it was taking like 5 seconds before, right? I don't think it's really speeding it up. In fact, I might have broke it. I might have broken it just now. I think I broke it. Let's put it back. I broke it. I thought that would work. Two 1003, 1004, 1005. Yeah. So it's roughly 5 seconds. Why didn't that work? Am I off by one maybe? Is it 13 here? No, it's broken. Maybe I'm off by one in the other direction. Is it like nth 11? Yeah, maybe 11. It goes to 11. I have 3 minutes. I gotta watch the clock. 1003, 1004, 1000. Okay. But how much faster is that? I don't have a stopwatch. I don't have a good stopwatch. And the benchmarker would take forever because it's sampling 100 times. It would take 500 seconds to time it. I could just stopwatch on my phone. Let's do that. Stopwatch. Okay. Ready and go. .68 with some delay for muscle memory, for muscles. So undo. Let's make it fair and build it first. So it doesn't count the building time. And then run it. Ready? We're comparing to 5.68. Nah, it's about the same. I didn't really speed it up. Maybe there's not many more than that number of matches. I could print it out. Print. Well, we'll just print out if there's more. I got a minute and a half to toy around with this. Found matches. Yeah, okay, it's not many more than 12. Sometimes it's 18, 15, but usually not more. Okay. Well, that explains why it didn't really help. But it is more efficient, right? Did I already lose it out of my undo history? I did. It is more functional, so we'll just keep it to that. So it's just if I got a minute to play around with this. It's just if nth 11 is sum. $30 seconds. Anybody else who's doing Advent Code 2021 day 21? Good luck. We got 20 seconds. So once again, Advent Code, what is it? It's Advent Calendar of Programming Challenges. 2 puzzles a day. They've been, part 1, part 2 have been pretty related to each other. From December 1st to 25th, they're Christmas themed, so they're pretty corny. But you can try out just to learn a new language or just to test your skills. Or if you really want to try, you can try to make the fastest times. They're really hard to do. Here, let's go. Dirac dice. Is that how you say it? There's not much to do as you slowly descend to the bottom of the ocean. Submarine computer challenges, because we're looking for Santa's sleigh keys that have been dropped into the ocean. That's why we're doing this. Submarine computer challenges you to a nice game of Dirac dice. Game consists of a single die, 2 pawns, and a game board with a circular track containing 10 spaces marked 1 through 10 clockwise. Each player's starting space is chosen randomly. Player 1 goes first. Players take turns moving. On each player's turn, the player rolls a die 3 times and adds up the results. Then the player moves their pawn that many times forward around the track. If a player is on 7, they roll 2, 2, 1, then that's 5 forward, so they stop on 2. 8, 9, 10, 1, 2. Okay. Each player moves, they increase their score by the value of the space their pawn stopped on, so that would add to 2. The game immediately ends as a win for any player's score reaches at least 1,000. Okay. Since the first game is a practice game, the submarine opens a compartment labeled deterministic dice, and a 100-sided die falls out. This die always rolls 1 first, then 2, all the way to 100, after which it starts over at 1 again. Play using this die. For example, given the starting positions 4 and 8, this is how the game would go. Blah. Player 1 gets 1,000. Since player 1 is at least 1,000 points, player 1 wins. At this point, the losing player had 745. So, and the dice has been rolled 993 times. Did they say that? Okay, yeah, it's an odd number. So it's counting player 1 rolls and player 2 rolls as distinct rolls. Got it. That makes sense. Okay, so that's our puzzle example answer. So let's put that as a unit test. And then what did they say? What does the input look like? Okay, so I guess we'll do the... Do I care? I don't care. I'm not even going to do the parsing. So we'll just say 4-3. 4-3. So this is no longer an input. It's just position 1, position 2. Okay, and then we have 4-3. Oh, I see. Player 1 start. I could do this faster if I was good, but I'm slow. I'm a slow speed coder. All right. Okay, I'm gonna assume for now that part 2 is going to operate kind of like part 1. We're not going to do any elaborate parsing. So let's make another const. So winning score is 1,000. What else did they tell us? Oh, the test was not 4-3, it was 4-8. There we go. And let's copy that to that. We don't know what that's going to be yet. Okay. So how do we solve this? Brute force? I mean, there's probably some math to avoid having that add, but why don't I just do brute force? So let well, we can just make these mutable. Let mute score 1. Let mute score 2. And then while, well, just loop, I guess. So we need to have the current die position. Die. Let roll equal die plus die. Well, die. It's 3 times the die plus 3, right? Die plus 1 plus die plus 2, right? We should get a 10 for die times 3 plus 3. We don't though. Why? Oh, that's the roll is 6. We have to add it to 4. Okay. Well, position 1. Hold on. What was the rule again? They increase their score by the value of the space they stopped on. Okay, so we just update position 1 equals position 1 plus roll mod 10. Okay, there's a weird thing. There's no 0, right? So I could just keep it 1 based. So the way we do that was we subtract 1, mod 10, then add 1. So if we were at 10 and we didn't move at all, we'd go to 9. Mod 10 is 9, plus 1 is 10 again. If we rolled 1 from 9, that's 1 from 10, it's 10 plus 1 minus 1. Mod 10 is 0, plus 1 is 1. All right, and then score 1 plus equals position 1. And then if score 1 is greater than or equal to winning score, then we need to keep track of rolls too. Rolls plus equal 1. What are we supposed to return? It's the product of the losing score and the number of rolls. So then it's so let, well, it's just the loop, whatever we get out of the loop to string, right? Actually, we can take advantage of the fact that rolls is out there, and we can just return the losing score. Break score 2, and then we can just say let losing score equal that. And then it's losing score times rolls to string. A slow speed coder is just a coder. That's right, Endurin. How are you doing, Endurin? This is probably going to be too slow, pretty slow, but it should still work, right? Then we get another roll. We add 1 to the roll. Here it's position 2, score 2, score 1. I don't know. Let's see if we get it. Let's see if we get the right answer. No, we didn't get the right answer. We're off by a lot. Let's print out what we got for the number of rolls and the losing score. Oh, we need to start that roll over again, right? Yeah, it's roll. When it gets to 100, it's supposed to start over. So what's the last roll before the die rolls over to 1 again? 94, 95, 96, 7, 98, 99. 100, 1, and 2. Well, I guess then why don't we just, instead of doing it this way, I'll just make a little function here. Die, and Well, I'm mixing my C++ with my Rust again. So it's going to be next die equal die minus die mod 100 plus 1. Yeah. Why is it saying that? Probably because it doesn't know what I'm returning yet. Die equals next. I need to turn this around. Let roll equal die. And then just say die equals that. Return roll. I can't do a modulo on a usize. Oh, I have to dereference first. I have to dereference twice. And a third time. Okay, so then roll 3. Is just roll die plus roll die plus roll die. And then this is roll 3 die. Okay, try again. Wait for your alarm to go off in 52 minutes. So are you saying that my voice is not sufficiently waking you up? Interesting. So I'm still doing something wrong in my math. What if we print out something here? Player 1 rolls something and now has points. Roll score 1. Moves to position 1. Position 2. All right, let's see it all. Let's print them all. Ten, 3, 14, 9, 20. These look correct. Yeah, 103, right? 100 and then 1 and then 2. Did I not do the modulo correctly? No, I think I did, right? 10, 3, 4, 6, 6, 7. So what am I getting wrong here? At the end, I guess. $745, 331. Oh. Oh. Okay, I computed the number of rolls incorrectly. This is 3 and 3. Yeah. Okay. That's what it was. We rolled 3 times, not 1 time. So we don't need this anymore. Yeah, so then I can just cargo run 21-1. This is our answer. All right, part 2. Now that you're warmed up, it's time to play the real game. A second compartment opens, this time labeled Dirac dice. Out of it falls a single 3-sided die. Yeah, it's a small detail, yeah. As you experiment with the die, you feel a little strange. An informational brochure in the compartment explains that this is a quantum die. When you roll it, the universe splits into multiple... Oh, no. Oh, God, no. One copy for each possible outcome of the die. In this case, rolling die always splits the universe into 3 copies. One where the outcome rolls 1, one where it's 2, one is 3. This game is played the same as before, although to prevent things from getting too far out of hand, the game now ends when either player's score reaches at least 21. Oh no. Using the same starting positions as the example, player 1 wins in that many universes. Player 2 merely wins in that smaller number of universes. Okay. Using the given starting position, it's one of those days where part 1, like, you just do a brute force solution, and part 2, you realize that you can't do it brute force anymore. Although it's played differently, right? We don't roll it 3 times. We just roll it once, right? No, it's played the same as before. So you do roll it 3 times. Okay, so then, like, just thinking on code here, we would, like, roll a 1 in one universe. In another universe, we would roll a 2. In another one, we would roll a 3. Then, we would roll a second time. Actually, the way it would happen is we'd have 1 and then another 1. A 1 and then another, and then a 2. Thank you for the follow. I appreciate it. All right, and then rolling it 1 more time. It's just duplicating that 2 more times, right? Oh, I did the wrong number. So these are the possible universes, right? So what are the scores here? Four, 5, 4, 5, 6, 5, 6, 7, and then back to 2, 3, 4, 5, 6, 5, 6, 7, 3, 6, 7, 8, 5, 6, 7, 6, 7, 8, 7, 8, 9. Okay, so there's in one universe we got 3, in one universe we got 9, and then from, if I were to sort this, just doing some quick sorting here. Watch my elite sorting skills. You wish you could sort this fast. Don't you? I'm the fastest manual sorter there is. Okay, so there are 3 4s. There are 3 8s. There are 6 5s, 6 7s, and then 7 6s. One 3, 3 4s, 6 5s, 7 6s, right? 1 2 3 4 5 6. No, there's 7. Yeah, 7. 6 7s, 3 8s, and 1 9. Now, does that tell me anything? Quantum computing? Yeah. The good thing is that it's only a 3-sided die, right? Wait a minute, how can you have a 3-sided die? Isn't that impossible in 3 dimensions to have a 3-sided die? Isn't the smallest die you can make have 4 sides? should I not worry too much about that? Because this is a quantum die. Well, the good thing about it is that player 2 then always has the same, each player has the same combination, right? So it just depends on their starting positions, really. Find the player that wins in more universes. How many universes does that player win? Okay, well, let's at least fill in the test. So for a 4-8, we get that huge number. It's the same starting positions, but how to think about this? I mean, we can just keep track of how many universes, you know, we have 1, 3, 6, 7, 6, 3, 1 of all the possible advancements we can make. Yeah, why can't I just have a counter for all 10 positions and just keep track of how many universes we ended up in that position? Actually, it's going to be positions and scores. So it's going to grow a bit more, right? Let me think about this. I can just reduce it. I don't have to consider these as unique. These all end up in the same landing spot. So really, I've just reduced it to this. All right. These are the possibilities. We either move 3, 4, 5, 6, 7, 8, or 9 steps, and in most universes we move 6. In very few we move either 3 or 9. So given a starting position, we have, what is this, 7 different landing positions, 7 different scores. Well, weighted by this number, right? I'm just trying to keep track of, I'm just trying to think of how would I keep track of this without having an explosion of memory, because like this is a huge number. Just like what was the previous day where we had where yeah, it was a string length, right? And to get the actual string length, we would have to have a terabyte of memory or something, like some crazy thing, or a quadrillion bytes or something. Gone down a rabbit hole of Google image search for a 3-sided die. Yeah, I don't think it's possible. A thick coin with 3 edges on it, and it always lands on an edge. There you go. I know what it had to be, Endorn. It would have to be a cylinder where it has to land on its side, and there are 3 sides to the cylinder. So if it landed on the narrow end, since it's rounded, it would just fall. That's what it'd have to be, MetroDev. So it would take a cylinder and cut the sides into like a triangle, but then leave the ends round so that it will tip over and it will have to land on one of the triangular faces. That's what it would have to look like. So you can't get a platonic solid. It can't get like a Dungeons and Dragons die. It would have to be some kind of weird shape like that. Anyway, back to solving the problem. I'm thinking like we have 10 game positions, and we can remember how many universes the player has a certain score and a certain position, and then that can just replicate itself, right? As long as we don't have too many different possible scores. Actually, we can just throw away the losing scores, right? When can we throw away the losing scores? It would help if I had still had printed out. Well, we're most likely. So in some universes, we'll never catch up, right? Is that true? Or is it always possible to catch up? Maybe it is always possible to catch up. I don't know how to solve this. I have an idea of how I might solve it, so just keep track of the combinations of score and position. And then for each combination, we would keep track of in how many universes did that happen. So what if we just start with that and see if it just explodes? Maybe we'll be lucky. So the loop sort of is the same, I guess. Only what do they want? They just want the winning number of universes. So then really we're just going to get a number out of the loop and turn it into a string. Right? And we'll start with thank you for the follow. I appreciate it. With, I guess, a vector? No, it had to be a hash set. I still think this is going to grow like exponentially. Yeah, let's just try a hash set. Let's make up a type. So struct state, and the state is going to have two things in it. Whoop. Hitting the wrong keys and I jump around. So it's going to have a position and it's going to have a score. Then we're just going to have a hash set of let mute actually every time we roll it splits, right? So won't we have a position 1 score 1, position 2 score 2? And we're just going to track the number of universes that combination is in. Maybe they end up folding together and I won't have to worry about it so much. So hash set of states. States. Well, I can just say hash set new. I'm going to have to do a derive. Was it equal hash partial equal? I think. Yeah, and so we import that, and I think it just doesn't know the type yet, right? Okay, so we're going to push into that is the state, our initial state, right? So position 1, 0, position 2, 0. And this is score 1, score 2. Okay, and then we don't need to track the rolls anymore. And we don't need to track the die or the score. All right, so then not a hash set, hash map. Because there's only one universe in which this happens. Import there. We don't put that or that there. Yeah, a map from state to number of universes. There's one universe in which we have the starting positions, right? And then every time we roll, basically I got to consider all the combinations and get a new set of combinations out of it, right? So let new states equal states dot map state to something dot collect into a hash map. Okay, now how do we collect this? What was the... Oh, hold on. We need to advance them until someone wins. That's what the condition is, right? So we have to keep going until there's a winner in all states. And then we basically have to sum up the values for all the for the two sides and see which one's greater. That's what it is. So then I need to turn this. No, I don't need to turn this loop. At the we have to detect the condition where there were no universes in which the game was unfinished. So can I just make a mutable unfinished here? And then say if unfinished equals 0, then we're going to count up the two. So let wins1, wins2 equal new states. Okay, we get down to here, it's just states equal new states. New states dot fold 0, 0, comma, accumulator. Well, we can just say wins1, wins2, comma, state. And then it's if state dot. Okay, it's already really confused, so it's not helping me with autocomplete. Let me try to get it to compile again. I want that line. Ultimately, we're going to say if wins1. It's the greater of the two, right? I forget how to do this in Rust, like to pick the greater of two things. Oh, wait a minute. Isn't it just wins 1 max wins 2? And then break that? Something like that? Okay, I have to do something in here. Yeah, let's just put something bogus in here. So the new states are going to be state and 0 again. Or state and 1 again. So the universe doesn't change. So what's wrong here? Oh, it's state and universes. Okay, oh, no, there's something still wrong here. Map exists for hash map, but its trait bounds were not satisfied. Oh, don't I have to say into iter there? Okay, and then single two tuple. Yeah, there. There we go. Fold exists, so hold on. I had to iterate here first, right? And let's put something bogus in here. So what do I want to put? Like wins 1, wins 2. Just to get it to compile, and then I'll modify this. Okay, good. Breathe. This is probably the easier of the two to do, right? It would be which score is larger than the other, and we add the wins to it. So put the brackets back. If state dot it's not helping me. What did I do wrong here? I guess it's not going to help me. Score 1 is greater than greater than or equal to winning score. Then, well, let's mutate wins and 1 and wins 2. Then wins 1 plus equal to state dot universes. Else, it's we count it for player 2. Why didn't it like this code here? Oh, I got this wrong. Yeah, it's a state and then universes. And there's no state dot universes. Okay. So if there are no games left unfinished, then we're just counting up the number of universes in which the 2 players won. So for every state, we say if the score 1 was a winning score, then in that number of universes, player 1 won. So add to player 1's wins. Otherwise, add to player 2's wins. And that gets all folded up, and we figure out which one won more, and that's what we return, right? So to actually play the game, I need to map. Here we go. An old state into a new state, right? I have to be careful here because if 2 things fold to the same thing, I want actually them to add together. So I don't want to do this with a collect. Actually, I want to do a let mute new states as hash map new. And I'm going to say for state universes in states into iter, and then just put a bracket here and end it. And we'll say new states entry new state or default plus equal universes. New universes. So we need to compute the new states in the new universes. Actually, we have to do this for all 7 of these down here, right? So maybe a helper function to do this for splits. State. And universes. Yeah, for new state, new universes. So need to have this splits in here. State u size. Oh, wait a minute. No, I actually need to have an iterator here. Yeah. Maybe I'll just do it by hand since it's not as much work. So it would be like for roll new universes in I'll just put it here directly. 3 1 4 3 5 6 6 7 7 6 8 3 9 1. Borrow that. And I got to do this for player 1, and then I got to do it for player 2. So, hold on. Let new state equal state where I can have it autofill this stuff. So this is just going to be state position 2. These don't change. State score 2. This one's going to be state score 1 plus score? New score? This is going to be state dot position 1 plus new position. Okay. Almost there. I just need to compute the new position now. So let new position equals state dot position 1. Oh, it's not an add, is it? It's just new. Plus, well, here same thing as we did in part 1, right? This one. State dot position 1 plus the roll minus 1 mod 10 plus 1, right? So let new score equal, what was the score again? It was at the ending position, right? New position. So I can just put that in there. I don't need a new score. Okay, and then we do the same thing for player 2. So position 2. Oh, no, I have to do that after 1 goes. So we got to do 1 and then 2. I have a feeling this is just going to explode. How these swap, actually. That's 1, 1, 2, 1, 1. And this is 2, 2, and 2. Yeah. Okay, well, I didn't use I need to actually use universes. It's not plus equal, is it? Oh yeah, it is. It's universes plus new universes, right? So the original universe is do we need to add in the... Yeah, we're accumulating, right? Yes. Okay. And then unfinished. That's if we determine at the end for all of these, actually. Oh, wait a minute, no. Hold on, let me think about this. It's They just iterate over the new states. Yeah, let's just do that every time. So we'll when we do this, we'll just do this every time. We'll say wins 1, wins 2, unfinished. Mute unfinished. Else, if state score 2 is greater than winning score, else unfinished plus equal universes. And then we'll say here, if... what happened here? No comma there? If unfinished equals 0, break wins 1, max wins 2. I have a feeling this isn't going to work at all. This is just going to just crash with out of memory. So maybe to be extra careful, I should just track... Maybe just print something. we can print here let mute step. Oh, it told us to go a certain number of things. Oh, the winning score is different. That's what it is. Mute step is, we'll just start on 1. Print line after blank steps, we have blank states. Step, new states length. Step plus equal 1. And then if it just gets to, if it looks like we're going to run out of memory, I'll just stop. Okay, so I need to change winning score. So this is winning score. Let's just change it here. No, I'm going to change it. I'm going to change it here. Winning score part 1. And then we have winning score part 2 is only 21. And then just chase the errors. So this was part 1, so it's winning score part 1 and part 1. And then down here it was 2 and 2. Okay, let's see if it gets how quickly it gets out of hand. It failed right away. Interesting. What did it do? Oh, it did part 1, that's why. I'm like, what the heck? Didn't print anything. Oh, interesting. Attempt to add with overflow. Okay, so it did slow down pretty quick after 8 steps, but we had an add with overflow at some point. 14 states, is that right? All is U size, yeah. I think it didn't work. I think my attempt didn't work. But I don't know if it didn't work because of it's a bug or because just this way of representing that is still like exponentially increasing in the amount of storage. What if we just print out all the states after step 1? If step equals 1, print line states. To do that, I gotta mark state as debug. Debug. Oh, new states. And I can't print that out. Why? I can print it out. Of course I can. Run that test. I forgot what the starting positions were. 4 and 8, right? So player 1 started at 4 and 8. So in 4 universes, it's kind of hard to see. Maybe I'll take this, make a new file out of it, and then hit enter at the right spots. What's it trying to parse this as? TypeScript? How about we just say it's plain? There we go. Fixed it. Okay, there's the different states after one step, and the number of universes in which those occurred, right? Actually, we shouldn't need to go very far because we already have... Oh, no, we have to play them all out, though, right? I wonder if we could do this. I just have a bug because we already have player in 8 universes. We have player 1 halfway to victory, right? But is this correct? The positions again, I keep forgetting, are 4 and 8.
So the score is always going to be the same as the position, right? Well, wait a minute. What's up with that? That's not right, is it? That's impossible. Okay, so I have a bug, because these are not possible universes. Right, none of these are possible either. Player 1 should always move, and they should always get some number of points. So I have a bug. Where's my bug? I must find that bug and slaughter it. Oh, hold on. We're using state here, not new state. That's the problem. I have to... Ooh. I have to... Oh, I need to just do that and then repeat this here and then put a states equal new states there. And start over again. There we go. Now let's see what we get after one iteration. Oh. No, it overflowed again. Get a lot more possibilities. I don't think this is right either. Can I split on the comma space state? I can. That makes it easier. Just hit enter there. And then I'll just have to fix these. That got kind of cut. Alright, does this make sense? This is after each player moves once. I don't think this is right, but we'll see. It might be because the position should equal the score, right? Right, there are 4 universes in which player 1 moved, what was it? Do I still have that in that comment? No. Because player 1 started where? I keep forgetting. Okay, it started at 4. And they'll be in one universe, they only roll a 1 3 times, right? So they get a 3, so they'll go to 7 only in only one universe. But then, okay, I should probably do it after player 1 moves, and then again after player 2 moves. No, don't need to save that. We'll just say after player 1 moves. I don't need to see this. Okay. That should say 2. There we go. Let's see this. Let's see it! Okay, so comma space state enter. Why does it say 2 universes? That's wrong. That should just be 1 universe. I guess the original universe needs to be inherited. Right? So I shouldn't be adding the old universes to the new ones, right? Because these are all off by 1. But that's probably not the problem. It should be 1, 3, 6, 7, 6, 3, 1. 1. Yeah, these are all off by 1. Okay, let me just fix that first. That's not why we're overflowing, but I can at least fix that, right? For a certain number of universes, we're in some new state. Oh, shouldn't the default be No, that's not right. Don't I just subtract one? Because the original universe, we want to reuse that one. We don't end the original universe. It just gets... So 1 becomes 3, not 1 becomes 4. 1 becomes... or 1 stays 1, 1 becomes 4, 1 becomes... no, 1 becomes 3, right. Oh, maybe it's multiply. Is it multiply, not add? I think it is add, but I think there should be a -1 there. Oh god. If from 2 different universes you get 3 different possibilities, then don't I multiply them? Yeah, I think I do multiply them. I don't add and subtract 1. Yeah, I think that's the correct answer. So down here as well. All right, let's try it again. See if the numbers look right. Still gonna crash, but that's okay. Overflow! I closed that new file, didn't I? All right. Right. In one universe, we're at 3, and one universe, we're at 7, because we started at 4. So we either moved 1 or we moved 9, which should go back 1. Right. So I think these are correct. Most universes, we moved 6, so 4 plus 6 is 10. Okay, and then what is after player 2 moves then? Did I already close it? I think I did. I gotta run it again. There's a lot of possibilities here. All of these. Enter. Not TypeScript. Why do I think this is TypeScript? This is plain text. Okay, does this look reasonable? There actually should be some cases where there's a 1, yeah. And in one universe that happened. Oh. I think I know why it's exploding out of control. Once we find universes where some player 1, we can stop. The game doesn't continue. So we can just drop them from the set. But we have to remember the wins. We have to remember... Okay, I know what to do. So we're going to just keep... The set's only going to contain the games that are still in progress. The games that were 1 will just drop out and just add to a win total. Okay, I think I know how to do this then. So... It's at this point. We don't want to do this if they won. So we need to keep a count of wins 1 and wins 2. And at this point here, we can just calculate that up front, right? Let new score 2 equal that. If new score 1 is greater than or equal to winning score part 2, then in those universes, player 1 won, and we don't have to track it anymore. Otherwise, these are possible universes where the game is still ongoing, So there we do insert something. So here we would just say wins 1 plus equal this sum, right? I guess we can compute that. Let new universes compute it once over here, right? And put that there. And there. Okay. And then I don't want to make a mistake, so I'm just going to copy, paste over to here. I just have to make sure that's a 2, because player 2 is going this time. New score for player 2. And it's wins 2. And then these two flip, because it's easier for me to think of it this way. That's 2, that's 2, that's 2. Okay, this could just be new score. There's no reason to have a 2 there. Does that look good? Player 2's rolling this time. We're getting the score for player 2. If they won, we just add those universes to win to player 2's total. Otherwise, we're in a whole bunch of new universes. Okay, and then we don't need to do this. We just need to continue until the new states is empty, right? If new states is empty, then break wins 1, max win 2. And then let's print this out again. I shouldn't have deleted this line. After blank steps, we have blank states, because this is probably going to still explode, right? Step new states length, but maybe it won't explode as horribly this time. Whew. Let's do this. No, we overflowed. We overflowed quite quickly. This is getting in my way, so let me just comment it out. Well, that's a bummer. On line 88, we overflowed. Well, they told us, is this too big? How big of a number is that? Maybe I need a big num. That should fit into 64 bits. Oh wait, U size is 64, right? How big is this number? Programmer, please. Yeah, that fits into 64 bits. Yeah, we got plenty of bits left. So let's print out the number of wins, I guess. Down here. Player 1 has 1 in blank, 2 in blank. Wins 1, wins 2. Why isn't that wrapping that? Oh, probably because this is too big. Concat. That. There we go. Ooh. And this shouldn't say after 2, should it? That's after 1. Where do we print it? Yeah, that doesn't really change anything, though. 49 states? No one has won yet. No one's won there. These numbers seem quite big, though. $88. I guess we can print it out here? Maybe it's not a product. Maybe I'm thinking about that wrong. It is, though, isn't it? Well, what am I doing wrong here? How about I just do, that might not help me. Let's see what I get. Oh, that's actually quite big. Quite a large number of loops. I didn't expect it to do it that often, to do that many. I don't know what to do. So there's a bug in here somewhere. It shouldn't overflow. The number should stay bounded to these two. So that should... Wait, it's I-32. Why is it I-32? I-64, please. Why you be I-32? In fact, let's make... They never go negative. Yeah, I feel dumb because you said it, Endorn. They're not all U size. U64, please. The 32-bit being the default bit me again. That hardly ever bites me. But I guess what am I doing? I think it bit me this time. So maybe this will work now. Yeah, we did it. Okay, so that's what it was all along. Cargo run 21-2. There's our number. See, look, it didn't explode. It collapsed again. Yay! We did it! Is anyone still around watching me? I got 32 viewers, so congratulations if you stuck with me. I finally got the answer. So I was afraid that the number of states would explode, and when the numbers overflowed, that was making me even more afraid that I was right about being wrong, if that makes sense. But the key was to realize that once some players win, those states can now be thrown away, because all we really need in the end is the win count. So after 3 steps, players start winning in many different universes. We toss those states out, and so we're left with, that's interesting. We have exactly 1 state after 9 steps. And so there's an additional step just to look at that one last state. So there's it'd be interesting to see what that state was. Let me print out that. I'm kind of curious what that last holdout state is. We'll say if new states len equals 1, print line, this may be interesting. The state left is that new states. I just want to see it, you know? Oh, it's a tie where they only need 1 more point. And so at that point, player 2 is going to win, right? No, player 1 wins. It's actually there are actually a lot of universes. This many. In 2.3 million universes, player 1 is going to win because why? Because he only needs to move once more. But wait a minute, how come player 1 is moving again? Isn't that... Oh, right, it's groups of 2. Right, so there are 2.3 million universes where player 1 is next to go and they're both tied at 20. There we go. And is that the same when I run it here? Yep. It's kind of cool. I like that. Okay, that problem was tough, but it wasn't insurmountable. Let's remove all the printing and benchmark it. So I probably don't need to track step anymore, right? It's going to tell me I don't use it, so I can just remove it. I'm glad that my model for tracking the memory worked out. So it grew exponentially, but decayed exponentially back down to 0. So the max memory was maybe 12,000. So not too bad. Make sure it doesn't print anything. What's that? Line 46. Oh. Indeed. I had an extra debug there. I want to get rid of all the prints because when we benchmark it, we don't want to be printing anything. Okay, so then cargo bench 21.1. While it's benchmarking it, let me see how I stood up to everyone else. Probably not that great, right? Let's see. Personal stats. Yeah, my target was under 1,000. I mean, it's not terrible, but it's not good either. So I bet most people just brute forced part 1. And then, yeah, because just like me, like a lot of people did it in under 13 minutes, but the same number, only a little bit more people took an hour or the rest of the hour to do the next part. 2.48 microseconds to do part 1. How about part 2? Slightly more time. 12.3 milliseconds. Okay. I can accept that, you know. Okay, so there's a bit of redundancy here. I'm wondering if I could collapse that somehow. After all, it is a quantum thing. So a quantum computer could do this in a way that wouldn't require 12,000 memory locations. Because it would just explore all of them simultaneously and come up with an answer right away. Is that the idea? I suppose I can start by just taking this and making it a constant. So let's do that. Const possible rolls. Roll possibilities. And that is a array of tuples of numbers. There are exactly how many? I don't know. Let's say equal. I'll count them. 1, 2, 3, 4, 5, 6, 7. 7. And we're going to use them here and there. Right, because of that being a constant now, these are borrowed, so I need to dereference them when I add. What other... Oh, the type isn't usize, it's U64. How come clicking that doesn't go where I want it to? U64, right? Oh, it was right all along. I just, yeah, okay. That was a reference before. I just had the type wrong. Okay. Make sure I didn't break it. Okay, now... I suppose if I collapse these two into arrays and then I can pass an index, what if I just do that? That'll make it cleaner. So positions is, there are two of them. Or actually another way would be to have player state. And then call this one game state. And player state is a position and a score. And then this is just players. Player state 2. The idea is that I can pass a player index to say which one moves, right? Okay, I need to derive the same things there. Okay, so then this is players, player state position 1 and score 0. Go away window. And this is position 2 score 0. All right. Yeah, so the whole point was so I can remove these 1s and 2s. So then how much of this do I guess it's the entire for loop, right? Might as well make this a method on the states themselves. No, because that is what type. That's a hash map. So it's just a function. So where to put it here? So I don't know, play game? Or move, I guess. Game move. Paste that code there. So what do we need? We need states. I can't call it move. Game move. States is hash map from a game state to a U64. Okay, and this has to produce another hash map output. And we also have to borrow mutably the wins of both players. So, and we'll probably want that just to be an array. So, mutable array of U64. Oh, and then we'll need to know which one is playing. So, player usize. And then at the, okay, so this goes into it actually. And out of it. So, new states. All right, so then this is state player position, right? What did I call it? Players. So score 1 is players player score. And wins 1 is wins player. Okay, and then the new state is could form that from the old state, right? I can just make this mutable. Hold on. I can make the array. Yeah. And then modify it and then put it into a game state. So let players, let mute players equal, I guess we're just copying from the state. Don't I have to clone that? think I do. This is going to be a problem, though. Clone exists for an array, but its trait bounds... Oh, because I didn't define cloning of that. Sure. I mean... Might as well just make it copy so that it's even easier, right? Because it's just 2 integers. So then I can just do an assignment, and it should figure it out, right? Hey, Endurin, we solved it. Playas, that's right. I misspell things, and it's now a rap song. Endurin, I was terrified that this solution of mine would explode in memory usage, but it didn't. It only went up to 12,000 positions in my map, and then collapsed back down once I realized that we don't need to track games in which a player's already won. At first I was tracking games until both players had a winning score, but that doesn't make sense. You stop the game when one player wins, and then you can throw away all the state of those universes. Yeah, about 12,000, yeah. Okay, the idea here was then we modify player's player. Position equals new position. Player's player score equal plus equal new position. And then this just becomes game state players. And then we do that. Okay, and then we just do game move in those 2 places where we use it, right? So we say states equals game move states wins 1. So wins needs to be equal to 0, 0. I don't use the array types enough. In fact, on the Rust series that I'm recording for YouTube, I kind of glossed over it and didn't cover it very well. I need to fix that. Maybe have a video that just talks about arrays. Okay, so the idea here is that we just do this twice with the 2 players, and now it's a lot cleaner, right? So hopefully I did that right. This should just be states is empty. Oh, this is breaks 0 max, or wins 0 max wins 1, right? Yeah, let's make sure I didn't break it. I did break it. How did I break it? Index out of bounds. Length is 2, but index is 2. 74. Oh, it's 0 based, not 1 based. So it's player 0 and player 1. It's like I was writing in Lua or something. So that probably doesn't help my performance, but let's benchmark it anyway. What's the difference between an array and a vector? There's a very important difference. The array is a constant length, and it's usually on the stack. But if you box it, or if it's on a heap object, it could be on the heap too. Hey there, Quantum Apprentice. How are you doing? We just finished Advent of Code Day 21. I'm benchmarking. Okay, plus 18% I think is in the noise. I was just cleaning up my solution for part 2 of Day 21. Yeah, sorry you missed it. Do you want to see my solution? Oh, what was really interesting is when I had a print statement in there. Did I delete it? Oh, I did. Wish I could go back in time and get it. Actually, I can. I can just I can hold down the undo key until I get my print statement back. It's like we're time traveling. Okay, that's what I didn't want. I wanted go forward in time. Actually, before I do this madness, I should have staged it in Git. Because all it would take is one bad keyboard hit and I lose everything. So yeah, let's stage that so I don't operate on this like a mad person. Now we're going to undo with confidence, because even if I screw it up, I will be able to get it back. Okay, that's actually what I wanted. I wanted that exactly. Okay, check it out. Check this out. So when we run this, my solution had
the concept of tracking the number of possible states of all the universes. And there are like quadrillions of them. So I was afraid that the number of states would explode in the same way the number of player wins. But it turns out it looks like it's going to, because it's going, exponential. But then when players start to win, and then we just drop those states where the players win, then it goes back down and it decays down to 0. And then we saw that there's one last state, and I'm like, oh, this is interesting. Let's actually print it out. And it's the case where the two players are 1 point away from winning, and there's just one final move. Right? And I think it has to do with the fact that the minimum you can advance is 3. So this is the slowest game takes 10 moves for player 1. Is this some sort of sleep sort? Should I go back and explain the problem? Because the problem is kind of interesting. It's kind of a fun problem, too. The amount of times you nervously held Control-Z through hours of work to get someone called nervously sweat about possibly hitting random keys uncountable. So you use the undo stack as well. So there are actually apps out there I've heard of where you can like copy your undo stack so that or archive it or save it in some way so that you don't run the risk of accidentally hitting a key and losing your undo or your redo stack. So I don't use the undo redo that much, but maybe if you do, then that's something to look into. Let me explain the problem because it's kind of a cool problem. Back to day 21. So they say that you're playing a game with the computer, and the game involves going around a track where there are positions marked 1 through 10, and you move by rolling a die 3 times and adding up those numbers, and then you move that many squares, and every square you land on, you take that number, you add it to your score, and you keep going until you get to 1,000, right? So it starts out pretty boring. And they say, well, because we can't have randomness in a question like this because the server's got to like check to make sure you get the same score every time, they give you a deterministic die that rolls a certain way every time. So it rolls a 1 and a 2 and a 3 and then up to 100, and then it starts over again. So that's fine. We figured out how many times we figure out which player wins and which player loses, how many points the losing player had, and multiply that by the number of times you roll the die. That was easy. Here's where it gets really interesting. They say, now instead of that deterministic die, you get a quantum die. It's a 3-sided die. And we were talking in chat about what would a 3-sided die look like, and I think the closest you can get to is if you take a cylinder and you round the ends, so it's kind of like a capsule, and then you shave off the sides so that it's triangular sides with rounded capsule ends. Then when you toss it, it's going to land on one of 3 sides. But anyway, it's a quantum die. Not only you roll it, but every time you roll it, the universe splits 3 ways according to whether it was a 1 or 2 or a 3. And so now it becomes a game of, or a challenge of counting the number of universes in which one player wins over another based off of the starting positions. And so if you did part 1 with brute force like I did, then part 2 becomes like impossible to calculate because it just takes forever, or you run out of memory. So you have to think of a way to consolidate the states that are possible. And I was really nervous about this, but it worked out. We're tracking we're tracking the number of times we have player 1 in a certain position with a certain score, and player 2 has a certain position with a certain score, and then how many universes that state exists in. And after every player moves once, I printed this out, and this is where it got interesting. We have 11,544 possible game states after each player moves 3 times. And I'm like, okay, the next step, it's going to be in the millions, right? But it turns out at that point, even though we have a lot of states, the players start to actually win in some of those states. And so we can toss those states because they no longer we don't have to track the game anymore after someone wins. And so the remaining states are the games that take a little bit longer, and more wins are being counted, and still until the very last state where this is the slowest possible game. Player 1 wins it in 1.6 million universes.
Get your quantum die back and don't give it to people ever again. Does NeoVim work with Visual Studio? There's a Vim key bindings and mode for it. Yeah, I've seen people use it. But at that point, why not just use NeoVim? I figure use whatever editor you like that fits your flow. But yeah, I hope I explained it well enough in a nutshell. I was just cleaning up my code, so let's go and do that. So it's just discard those changes. Oh no, so much for that undo stack, right? That's okay, we don't need it. So cleaning it up, I consolidated the two positions and the two scores into one structure and just have two of them. And now the wins is also an array. And this is, I want to get back to what was asked in chat around the time the raid happened. What's the difference between an array and a vector? So do I use a vector in this code? I don't think I did. An array in Rust looks like, well, hold on, like this. It's just square brackets with elements in it. And the hint is telling me that it's an array of size 2 64-bit integers, because that's what's needed here. I could have written this differently and put a vec there. And now we have a vector of unsigned 64-bit integers. The difference here is that this vec is storing the numbers on the heap, and we can resize it. So I could do something like wins.push another 0, and now we have 3 wins instead of 2. So that just reallocates more memory if the vector didn't already have some in reserve. But it's like standard vector in C++, or like if you did a new or a malloc of some memory and just used it as just storage for your numbers, right? But when you go to an array, it's a bit different. You can't change the size of an array. The number of elements is actually baked into the type. And so it's more like it's more as if you had a 128-bit integer here. It's literally stored on the stack, that taking up 16 bytes. And the compiler knows that the first 8 bytes are the first element of that array, and the next 8 bytes are the second element. So if you had a array that was too big, you would get a stack overflow in your code. And at that point, you would use a vector instead, because then it goes onto the heap. Or there's other options, like you can put it into a box, which is in Rust one of the ways you can take a value and make sure it goes on the heap. But yeah, vector lets you resize it because it's just it tracks the size at runtime and puts it always on the heap. Whereas with an array, the size is locked. It's built into the type, so you can't change the size, and therefore it can go on the heap because the size of the value is always known at compile time. I should have said that at the beginning, Endurn. The size of an array is known at compile time because you know how many elements are in it. You don't know the size of a vector. In fact, you can't have it on the stack because its size is unknown if you were to try to put it all on the stack. So instead, the vector class really is just a pointer and a length. The pointer points to something on the heap. Anyway, sorry about the long-winded explanation. I gotta iterate on that explanation a bit because I want to make a video about that. That's actually something I want to do now. Explain the difference between an array and a vector in Rust. Because it gets into a lot of subtlety in the types and then where things are stored, whether it's on the heap or the stack. And someone new to the language will be like, well, I don't see any difference between them. In fact, all I'm doing is putting those 4 characters in front. What's the difference? There's a huge difference. Learned today that you can use pointers to increment through a section of memory like it's an array. Yep. You can. You can even do that in Rust if you take off the safety bolts. So an array really is like you would think of lining up the values in memory. And so if you have a pointer to any one of them, then all you need to do is add or remove from the pointer and you're moving between elements. In fact, when you're making high performance stuff, highly optimized code, you want your data to be arranged in arrays because then it's more friendly to your cache. because the way cache interacts with the CPU, it usually loads and stores large slices of arrays or memory. And so if you already have the data you're working with, like co-located in the same general area in memory, then the cache performance is better. It's like only takes one cache write or one cache read to get a whole bunch of values. Whereas if you had like a binary tree and you have a lot of pointers between nodes, so they could be not co-located at all. It could be quite distant from each other, and it could be a huge hit to your cache performance. So today you co-located a section of memory and use it like an array. There you go. Or callocked a section of memory. Yeah. So yeah, arrays are good for performance because of how caches are designed. Do I need to do anything else here to clean up this code? I actually like how consolidated this looks. This looks like a mess. I kind of feel like I should take this and just hide it away inside of a method of game state. In fact, I'm going to do just that. We're going to make a game state new that just takes positions. Implement game state. Make me a function called new that takes in position 1. Actually, why don't we just make it an array? So positions. Use size 2 of them. And gives me a self. Self is a keyword that maps to the type you're implementing. It's just sort of a shorthand. So players, at this point I can just paste it really. Call this self. And then this is position 0 and this is position 1, right? Then we can just call game state new down here and to clean this up quite a bit. So this is game state new, position 1, position 2. There we go. So here again, I'm using an array. Rust makes it really convenient because you can form you can form arrays out of values that on the stack, and Rust knows to put them side by side on the stack for you, or maybe it would optimize it away as, oh, they're already next to each other in memory, so just pass that array as is to this new function, right? It gives the compiler a lot of room to optimize things. You're saying, I want those two positions next to each other in memory so that we can just index them like you're saying, Quantum Apprentice, like using a pointer. You just get one position, increment the pointer, now we have the other position. Are we allowing bad language because you got around the filter? I'll go ahead and allow it. What's missing is leading commas. You can probably get leading commas to work. You mean like this? Although, like, I don't know what you do for the very beginning. When you see me write and I don't worry about the indentation, it's because when I hit save, Rust formatter just reformats it according to the rules that I've set up in advance. Learning C++ next month? Cool. Nope, you're learning Rust. It's not mute, which means it can optimize further with no alias. Oh, you mean this? Yeah, we're not borrowing that array. We're getting an array in, yeah. The formatter removes extra parentheses? Yeah, I think it does. Either that or we get a warning. Oh, look at this. I don't need to clone because I made it a copy type. Excellent. It's a copy type. Yeah, so where would we might have extra parentheses here? I don't think the formatter actually removes those because it wants to keep them so that it can spank us and say, unnecessary parentheses around if condition. You must remove them. Okay, remove them. Thank you. Where the formatter would help, I think, is if you have extra parentheses around values, like if I did that. It'd remove one set of them. If you have an incredibly large number of parentheses that you didn't need and you hit save, it removes all but the last, and it keeps the last again to tell you don't need them. When in doubt, clone it out, unless you make a copy type. Yeah, so if you saw me write this at the time, I was saying we can make this copy because really it's just the size of two numbers. Where you want to be careful about copy and using clone is where you have
a structure that's potentially very complex and large, and either is just going to make your program slower because you're making lots of copies of something that's big, when you could have just gotten a pointer to it, or in Rust's case, borrowed it for a while. Or if the clone is complex, like it takes a lot of CPU to compute a copy of something. More often than that, it's just that it's the thing is large. But I justify if something is like on the order of 10 or less numbers, it's probably okay to just copy it. And then that makes things a lot easier. You don't need to worry about borrowing or cloning. The copy is implicit. Everything's nice. Spelling error in the word Vulkan. There's still some value in learning OpenGL, right? Because it's used in a lot of examples online to learn graphics and 3D graphic concepts. I still haven't learned Vulkan, mostly because of how useful it is to know OpenGL. You can use OpenGL in on mobile, because there's OpenGL ES, which is based off of OpenGL 2, I think, or 2.1. So I don't know if you can say the same about Vulkan. Do they have Vulkan on Android? Right? I don't know. Maybe if they do, then maybe you're right. Just go to Vulkan. I don't know. I think I'm done cleaning this up, right? This, I calculated the players out here because it was just easier to do that. Index on player. I think I'll just keep that. And does this or default make sense? I think it's so, because default means that if we didn't have an entry for that state, then start with 0 universes and then add that. And if it's, we need to handle the case where states collapse into each other. That's why we have plus equal. Yeah. I could have, well, no. Game move only is used for part 2, so I was going to say I could have made that a parameter, but game move is only used for part 2. Oh, I need to clean up where I declare a lot of this stuff. Let's move this around. I like to have types first. Well, constants first, then types, then functions, then the main stuff. So this game move should move up, and I should probably call it like part 2 game move or something. That's okay, we can call it game move. And yeah, I do like to sort my functions alphabetically. This is sort of my main, so it's not, I'm considering that like not part of the other functions. Although I guess I should, I don't know. I didn't break anything, right? Just testing. Still works. Yeah, I think this is good. I probably didn't need to do that. I could have done it more in a clever way, but I was lazy. This was lazy too. I could have done this with an array also. I'm not going to bother cleaning that up. I like my part 2. I'm going to stick with that. So, yeah. Because I can toy around and see how the leaderboards are doing. So T-Bod, I'm never going to catch up to T-Bod. Looks like we've had some drop-off. How about in Primogens? So we had some people complete it with me. Yeah, we see these holes. Some people skipped day 19. Then we figured out that like maybe at least half of the people who did 20 skipped 19. Yeah, looks like it. What about, where is Prime on this list? The Primogen 69. I gotta tweet. I gotta put that in Discord. Hold on. This is important.
I gotta put this in Primogen's Discord. It's very important. I'm gonna say the Primogen looks like you found your spot on the leaderboard. This is on the new leaderboard, yeah. 69. Okay. And then, okay, Tien hasn't done this one yet. Okay, what else can I look at? The stats? So a lot of people completed part 1 but haven't done part 2, and that makes sense because this is backwards. Usually this year, part 2 has been easy and part 1 has been hard. This one, it was flipped. Okay, well, I guess I'll be back. Maybe in 22 hours. Depends. I might have something going on then. So if I'm not streaming tomorrow, then we'll catch up on the 23rd. Let's see if someone else is still struggling with it. Okay, I don't see anyone I'm following, so we're gonna go browse creative, software and game development. Juicebox Hero is doing admin to code. I'm doing admin to code. Really? Okay, let's raid Juicebox Hero then. Turn off that audio. All right. You're welcome, Sure Shock. Yeah, and Quantum Apprentice, have a good night too. So we're gonna raid Juicebox Hero. I'm still seeing an ad, but hopefully she's still working on it. She's doing it in JavaScript. Okay, let's cheer on Juicebox Hero. I'm waiting for the ad to go away. I don't want to raid someone who's like already gone. Okay, good. She's still working on it. Here we go. See you there.